Hello friends. So we were discussing about cross product or vector product, and in the previous video we discussed about the important properties associated with cross product or vector product. So here we'll extend the same discussion to the unit vectors. Okay. Now we all know that every discussion related to vectors, it has to have x, y and z axis come into play, okay, come into the picture. Okay, so let's draw them. So this let's say is the x axis, this is the y axis, and this is the z axis. Now we know I cap, j cap and k cap, they are the unit vectors in the direction of x, y and z respectively, and they all have unit magnitude and they are directed along x, y and z axis respectively. Okay, so here in this video we'll be discussing about the cross product of the unit vectors. So first let us take I cap and see how the cross product of I cap with itself works out. So I cap, it has unit magnitude, and both I cap vectors, unit vectors, they are in the same direction, which means that the angle between them will be 0 degree. Now the definition of cross product says that if two vectors are multiplied through cross product, it is AB sine theta, the magnitude. So here it will be magnitude I cap sine 0 degree, which is equal to 1 into 1 into 0, which will be 0. So the cross product of unit vector I cap with itself is 0. Same goes for cross product of j vector with itself and cross product of k vector with itself, because they are all in the same direction. J vector is in the direction of y axis, k vector is in the direction of z axis, and this is in the direction of x axis. Now we all know for parallel or anti-parallel vectors, the cross product or vector product is 0. So from here, from this discussion, we conclude that the cross product of unit vectors with themselves gives us 0 as result. Okay, this. Okay, now let us say we do the cross product of I cap and j cap, cross product of I cap and j cap. Okay, the angle between them is 90 degree. Theta is equal to 90 degree because x and y, they are mutually perpendicular with respect to each other. So as per the definition of the cross product, I cap cross j cap will be I cap modulus j cap modulus sine 90 degree, which is equal to 1 to 1 to 1. The magnitude will be 1, and the direction, it has to be perpendicular to the xy plane. Okay, it has to be perpendicular to xy plane. So the direction of the resultant vector will be in the direction of, sorry for this, okay, the direction will be perpendicular to the xy plane, so it will be like this, in the direction of z axis. And we have unit magnitude directed along z axis, which means it is k cap. So the cross product of I cap with j cap, it gives us k cap as the resultant vector, because it has unit magnitude and is directed along z axis perpendicular to xy plane. That is the rule of cross product. The resultant vector is perpendicular to the plane containing the two vectors. Those are multiplied using cross product. Similarly, if let's say we do the cross product of, let's say, ij jk, okay, let's say we do the cross product of this y and let's say z, that is j cap and k cap. So here j cap cross k cap will be the same, j cap magnitude, k cap magnitude, sine 90 degree, because they are perpendicular to each other, mutually perpendicular. That will be 1 into 1 into 1 unit magnitude, and the direction will be perpendicular to the YZ plane, the YZ plane, and that is along x-axis. So a vector of unit magnitude directed along x-axis, it means it is I cap. So j cap cross k cap gives us I cap. Sorry. Similarly, let's say we do the cross product of, let's say, k cap and I cap, okay, the cross product of k cap and I cap. So again, they are of unit magnitude and the direction between them is 90 degree, because they are mutual perpendicular. It is 1 into 1 into 1, which is 1. So the direction of the vector will be perpendicular to the xz plane. So a vector directed perpendicular to the xz plane and of unit magnitude is nothing but the j cap. It is directed along the y-axis and this is j cap. So from here we conclude that k cap cross I cap, it gives us j cap. Okay, this. So I cross j, it gives us k cap, j cross k cap, it gives us I cap, and k cap cross I cap, it gives us j cap. Now if we change the order of the vectors like this, like let's say we do j cap, okay, let's use the blue ink, okay, because yellow is not that visible. Okay, now if we change the order of the vectors, now let's say we do j cap cross I cap. The magnitude will stay the same, but it will be in the opposite direction, minus k cap. It will be in the opposite direction to k cap, like this, minus k cap. in minus z axis, like that, opposite to that. Similarly, if here we change the order, that is k cap cross j cap, here if we do, it will be minus I cap. It will be opposite to the x axis in this direction, minus x, and will be minus I cap. Similarly, if we change the order here, I cap cross k cap, it will be how much? It will be minus j vector. It will be minus j vector, opposite to the y axis in the minus y direction. It will be minus j cap, this. Okay, so these are the important concepts related to unit vectors and cross product. Okay, here, so if there are two vectors, okay, if let's say there are two vectors, a vector represented as ax I cap plus by j cap plus, sorry, this is ay j cap, okay, not by, by mistake I wrote by, it is ay, okay, ax I cap, ay j cap plus az k cap, and another vector b vector is represented as bx I cap, by j cap plus bz k cap, where ax, ay and az are the x, y and z components of a vector, bx, by and bz, they are the x, y and z components of b vector. So the resultant c vector formed by the cross product of a vector and b vector, that will give us the result. We have to multiply through cross product technique both of them, both the vectors. Ax I cap plus ay j cap plus az k cap cross bx I cap plus by j cap plus bz k cap. Now here, bear in mind that these things will play. I cap with I cap, j cap with j cap, k cap with k cap, the cross product will be 0. I cross j is k, j cross k is I, and I cross k, k cross I is j. These things will happen. So the final result that we'll get, it will be something like this: ay bz minus az by I cap plus az bx minus ax bz j cap plus ax by minus ay bx k cap. This will be the final result, the representation of C vector. So another interesting way in which we can represent the cross product is in determinant form also. So in determinant form, C vector, which is represented by the cross product of A vector and B vector, it can be represented as I cap, j cap, k cap, ax, ay, az, bx, by, bz, the determinant of this, and it will give us this same result. Okay, so this is the discussion related to unit vectors directed along x, y and z axis I cap, j cap, k cap and their cross product, and how the results that were obtained from that can be used to determine the cross product of two vectors, which gives us this result, which can also be represented in determinant form. Okay.